So today I want to walk through this model I've been building, show all the pieces and parts that go into it. And I also want to show, how powerful the help of AI can be for people that are like me, have always been really interested in getting into building sports models, that kind of stuff, but never had the full ability to make it possible. You have to be, before AI, you had to be really good at coding, really good at math, and have a ton of free time to put these things kind of things together. But now, as long as you have like a kind of basic subset of understanding, you can go a long ways with that kind of stuff. If you just kind of understand how the models work on a basic level, you don't have to be an expert in the nuts and bolts of it, that kind of stuff. And what I think is incredible is that the AI is already good enough to help you put some really sophisticated sports models together. And that's just today. I mean, the models are only gonna, yeah, the AI models, I mean, are only gonna get better. I think a lot of the edge in sports betting will be more democratized and kind of less hidden behind the kind of ability to put these models together, and it'll be more creative. It'll be more about who's able to find an edge in the market with the help of the AI, not just the ability to put a model together. All right, so I'm going to go over the model I've been working on so far. Mainly where I'm at right now, I've been doing a lot of work on the basketball analytics side of the model, which is trying to figure out which teams my model thinks are the best, the worst, and how every team stacks up against each other. Done a lot of work getting data in, a lot of stuff around games that have been played, box scores, schedule, basic stuff. A lot of data involved was getting all the right schedules. So you have, there's kind of three different buckets of trying to get schedules that go back. Like here you have 2011. I think it goes back to, I thought it went back to 2010, but I guess not. And all of that's for kind of, oh yeah, here you go, 2010, 2011. All that's for mostly back testing and trying to figure out kind of like baseline historical projections, which I'll get into in a minute. And then there's more games that are this year's schedule, which is more relevant to current teams, taking in the games they've played, which has all the relevant stats for not just the scores, but rebounds, all that kind of stuff, player stats somewhere, and then future schedule so that it can try and project, yeah, here's all the games that haven't been played yet. That's games that'll be, the model will use to try and project and see how it does. We also have team rosters, as well as some more advanced projection stats that we've scraped from sites like Darko. Darko is like the best all-around stat for basketball players. It's kind of like a WAR in baseball, wins above replacement, if anyone's seen Moneyball. We also have some historical odds data. This is a lot of data going back, just trying to, this was the betting lines for games that have already happened, so it can try and backtest on those games. And there's also a normalized schedule, which is basically trying to equalize the schedule for strength of schedule, so the model doesn't overrate teams for playing bad teams so far. Then there's the actual model itself, which is the main goal of the model is trying to get a true rating of a team's offense and their defense separately, and then it adds those together to create the net rating. And that's how it ranks teams so far, is just based on the net rating. The flow of how the model works basically is it applies what's called Bayesian statistics, which is it tries to develop a prior of how strong it thinks a team was, and then every game that's played, it updates to see, try and figure out what would be the most correct rating for that team's abilities based on the team it played, and it just keeps iterating on that process. So this piece of code here, process model, what it's pretty much trying to do is make connections about the historical team stats and make assumptions that it can make about a team that goes beyond its scores in a game, which is like things like, if a team has a lot of turnovers, that would usually indicate a lower net rating, and if they have a really high 3-point shooting ability, it would indicate a higher net rating. And so it's trying to make connections at all different kinds of stats with that kind of stuff. In this piece of code here, dynamic model, it basically takes the same stuff we're looking at from process model, and it tries to see how the numbers process model is looking at change over the course of the season. So from game to game, if the team has a good game, bad game, it tries to figure out how much it should update it just based on that one game. And this code here, simulation, It basically takes the ratings that we've taken from the other stuff we've gone over, and it tries to use what's called a Monte Carlo simulation, which is just a way of trying to accurately predict future games based on the net ratings that we've put together. So I'm not going to go over every little piece of code in the model, but my point is that I am definitely not any kind of super coder or math whiz. I've just learned a little bit about this stuff over the years, like the basics, the very basics. And now, because of AI, I'm able to try and put together my own model in a way that I never would have been able to before. And I think there's a lot of people in a similar situation who are able to start doing stuff like that now. All right, so now I'll show you how I've been working on the model. Basically, as I said, I've done a lot of work on the basketball analytics side, trying to accurately understand the quality of each team, that kind of stuff. And now it's more trying to get it ready to actually start betting on some markets right now. So we call backtesting, which is looking at past results of betting markets and getting the model to see how it would have done, and if it would have had a profitable track record in the past, then you start betting it, and if it's not, then you kind of keep adjusting it until it would have had a profitable track record, and then you see from there. So for right now, it's asking me how I want to optimize the back testing, and for stuff like this, the model's really intelligent. You just let it tell it to go ahead however it thinks is best. A lot of times it's working, and it'll either just complete what it's trying to do, or it'll ask me to go do something for it. Sometimes it can go get data itself, and sometimes it'll have to ask me to go get any extra data it needs. Basically, it was just working a lot of infrastructure for making sure the back testing can run as well as it possibly can. Now it's giving me some options for how I want to move forward. So now it wants to do this next step here. Run your dynamic model once per season to produce all ratings mean.csv. Add a small driver script that loops over season. So basically wants to produce this season's standard as well as a standard for the past seasons that it can reference. So I think it's what it wants to do. Something that's crazy to me is up until recently, I've been using AI tools for quite a while, and up until recently, they just weren't good enough to do this kind of stuff. They would eventually, you'd get like an hour or two in, and then it would kind of have an error, and it would just kind of start looping on the error, and you'd never get close to a model of something like it as good as it is right now. So you can see while it's working, you can see what it's thinking while it's working. So here's the output of the model right now. Here's how it ranks all the teams. OKC in first, no surprise by a big gap. Likes Denver, likes Minnesota, likes Cleveland, likes the Knicks. Also not really a big surprise that top three teams are all in the Western Conference. You got Cleveland, New York, Detroit, but definitely likes the Western Conference a bit more, which is not surprising. All right, so it's finished working here. Just done some more work to kind of standardize and make sure the back testing, when it does runs as well as it can, because it's really important that you can't just run it and hope it works out. I mean, if you have even a small misunderstanding in the code, you'll get the wrong outputs, and it'll be useless even if you have the best model in the world for the rest of the parts. So I'll get more into how exactly I'm working with Codex here, the AI, in building out the model in the next video. I'll go deep dive on exactly how to work with it and everything. I just wanted to show a little sample of how it works and how powerful it is for people who want to put together their own model but couldn't do it by hand. I mean, if I did this by hand, even if I could do every part of it, it would take probably a year, and I've been working on this for like a week, which with the AI. So